Good morning. Welcome to another edition of A for A Levels by my tutor. Now, if you like my previous videos, you can subscribe and like this video for future notifications. Today, we're going to do Mechanics 2020 paper 42 for February-March. Let's go. A lorry of mass 16,000 kilograms is traveling along a straight horizontal road. The engine of the lorry is working at constant power. The work done by the driving force is 10. In 10 seconds is 750,000 joules. Find the power of the lorry's engine. Power equals work over time. This equals 750,000 10 seconds. This is 75,000. 75,000 watts. Okay. There's a constant resistance force acting on the lorry of magnitude 2,400 Newton. Find the acceleration lorry at an instant when the speed is 25 meters per second. So, power equals driving force times velocity. So the driving force is your power, which is 75,000 over velocity 25, which will equal 75,000 divided 25. So 3,000 newtons. 3,000 newtons. Now, resultant force equals to mass times acceleration. Resultant force is your driving force minus resistance equal your mass, which is 16,000 A. A equals to 600 over 16,000. Equals 3 over 80 meters per second square. That's it. Question 2. Particle P of mass 0.4 kilogram is on a rough horizontal floor. The coefficient of friction between P and the floor is mu. A force of magnitude 3 Newton is applied to P upwards at an angle alpha above the horizontal. When tangent alpha equals to 3/4. The particle is initially at rest and accelerates at 2 meters per second square. Find the time it takes for P to travel a distance of 1.44 meters. So this is a question of Suvat. Acceleration is 2. Initial velocity 0. Displacement 1.44. So you're asked to find time. So use the equation S equals to UT plus half K. 1.44 equals 0 plus half times 2 times T square. Okay. So you get T equals to 1.2 seconds. Find mu. Now in this type of question, it's better if you draw out the problem. So this is your particle. This is 3 Newton. This is your friction equals to mu R. This is your R. This is your weight equals 4 Newton. So R will be 4 Newton. F will be 4 mu. This angle is tangent, arctangent, 3/4. Okay. So again, resultant force equals to MA. A is moving forward equals to 1 equals to 2. 3 sine alpha, which is a force pulling it forward, minus your friction equals to MA. 0.4 times 2. Okay. So you have alpha is, tangent alpha is 3/4. This is 5. Alpha is 3/5. 3 times 3/5 minus 4 mu equals to 0.8. 4 mu. 3 times 3 is 9/5 is 1.8. 0.8. So mu is 0.2. That's it. Diagram shows the vertical cross-section of a surface. A, B, and C are 3 points on the cross-section. The level of B is H above the level A. The level of C is 0.5 meters below the level of A. Particle of mass 0.2 kilogram is projected up the slope from A with initial speed 5. The particle remains in contact with the surface as it travels from A to C. Given that the particle reaches B with a speed of 3 meters per second, and that there is no resistance force, find H. So the particle here goes up with 5 meters per second. Okay. So loss in kinetic energy will be the gain in potential energy. So half and the loss is 5 square minus 3 square mgh. Okay, 5 square minus 3 square is 16. 16 over 2 is 8 equals to 10 h. H is 0.8 meters. It is given instead that there is a resistance force and that the particle does 3.1 joules of work against the resistance force as it travels from A to C. Find the speed of particle when it reaches C. Okay. Again, the loss of kinetic energy, half m. Using the m, you cannot cancel. 5 square minus 3 square equals mgh 0.2 times 10 times what's the h, 0.8 plus the work done. Always work done against friction is a gain in energy. 0.1. So this is 25 minus v squared equals to 2 times 0.8 1.6 plus 3.1 is 4.7. 0.1 square equals to 25. Just C. Oh, reaches C. No wonder. My bad. So here, instead of, I thought it reaches B. That's why you have a problem there. So the speed at C will be larger than 5. So here, so this will be V square minus 5 square. So this is V square minus 25. V square equals to 47 plus 25. V equals 72 square root of 72 meters per second. Okay. Next question. Cyclist travels along a straight road with constant acceleration. He passes through points A, B, and C. The cyclist takes 2 seconds to travel along each of the section A, B, and BC and passes through B with a speed of 4.5 meters per second. The distance AB is 4 or 5 of the distance BC. So you have, again, always model your question. A, B, C. So along 2 seconds here and also 2 seconds here. And passes through B. So the speed here is 4.5. The distance AB is 4 or 5, the distance BC. So if here is S, so this is 4 or 5. Find the acceleration of the cyclist. So you have S, you have T, you have V. So what are the formulas that you have? S equals to UT plus half AT square, V square equals U square plus 2AS, V equals U plus AT. Okay, let's put this as U. So you're going to use V square equals U square plus 2AS. No. So S equals UT plus half AT square. So for the first part from A to B is 4 over 5S equals to 2U plus half A square. This is 2. So you have here 4S equals to 10U plus this 2A times 5, 10A. Let's write down all the equation. equals ut plus half at square. Okay. Now I'm going to use this on the second part. No, it's going to be at the second part. Okay, these two equations. Rub this. Now the second part from B to C, I'm going to use this equation. S equals to ut a. Okay, so S equals U is 4.5. So plus half a square. So you can cancel this is 2. So S equals to 9. Okay. Now if for AB, you're going to generate a few equations. So AB, if I use V square equals to U square plus 2AS. So 4.5 square equals U square plus 2 times A times 4.5S. Okay, so 4.5 square this question seems a bit challenging. 20.25 plus U square is 8/5A, and substitute the S, 9 plus 2A. You have to find a U to substitute. Okay, what I'm going to do is I'm going to use this equation. S equals ut plus half at square. Be the same, probably. This I'm going to use for all of the journey. A to B. S equals ut plus half. So you have this will be 9/5S equals to 2U plus half A times. Okay. What I'm going to do is you're going to generate 3 equations to solve this because there are 3 unknowns. So again, I'm going to use this S equals ut plus half at square so that I do not have equals to 2U. This is for U plus half A2 square. So this is U divided by 2. U equals 2 over 5S. Minus, this is 2A divided by 2 is A. So I'm going to substitute by S. So U equals 5, 9 plus 2A is A. U equals to 18 over 5 plus 4 over 5 minus 1 over 5A. Okay. So substitute S and U, 9 plus 2A, 4, 5, 5A plus 8A. Finding the acceleration. This is 81 over 5 plus 18 over 5A equals to, looks a bit complicated. Okay, 22 over 5, 18 over 5A. Equals to 981. 9 over 5. So A equals to 0.5 meters per second square. Okay. Looks a bit challenging, but it's quite okay. It's quite okay. So it needs 3 equations to find 3 solutions. Find AC. So once you have A, you can find S. What is S? S is 9 plus 2A. So S equals to 9 plus 2A. Equals to 9 plus 1 equals to 10. So AC 9.5 S is 80 meters. Okay. Planar forces of magnitude F 3 Newton, 6 Newton, and 4 Newtons are shown in the diagram. Given that alpha is 60 and that the resultant of the 4 forces is in the direction of the 3 Newton force, find F. Okay, so you have to resolve vertically. Vertically, it is in equilibrium. F sine alpha, which is the force going upwards, plus 4 sine 30 equals to 6. So F sine 60 plus 4 times half equals 6. F equals to 6 over 6 minus 2 sine 60. Sine 60 is root 3 over 2. So 8 over root 3. So it's 8 root 3 over 3 newtons. Okay. Given instead that the 4 forces are equal, find the values of F and alpha. Okay. So again, from this equation, the first equation, f sine alpha equals to 4. First equation, f sine alpha equals to 4. Now resolving horizontally, you have f cos alpha plus 3 equals to 4 cos 30. So you have two equations and two unknowns. So here you have 4 cos alpha equals to, cos 30 is root 3 over 2. So this is 2 root 3. Equation 2. I'm going to eliminate f by dividing. Sine alpha over cos alpha is tangent alpha is 4 over 2 root 3 minus 3. So alpha equals shift tangent. It's quite a large angle. 83.4 degrees. Now, 1 square plus 2 square, you have f square equals to 16 plus 2, 3 minus 3 square. 16 plus 2 root 3 minus 3 square. Square root. The answer is 4.03. 4.03. Okay, good. On a straight horizontal test track, driverless vehicles with no passengers are being tested. A car of mass 1,600 kilograms is towing a trailer of mass 7,000 kilograms along the track. The brakes are applied, resulting in a deceleration of 12 meters per second square. The braking force acts on the car only. In addition to the braking force, there are constant resistance forces of 600 newtons on the car and 200 newtons on the trailer. So you have trailer, wow. It ran off. Okay. This is the car, this is the trailer. It's moving this direction. So the force here is 600. The force here is 200. So this is the force on the tow bar. This is 1,600 kilogram. 700 kilogram. So A equals to minus you have braking force. Put it as B, which acts on the car only. Okay, so what you're gonna do is this force X, the braking force X on the car, we're going to isolate this trailer to find the magnitude of force in the tow bar. So again, resultant force equals to MA. So F minus 200 equals to 700 times -2. Okay, so F is minus 1400 plus 200, so it's minus 1200 Newton. So the magnitude is on the opposite direction of what I have drawn. So instead of the force going this direction, the force is going this direction on the tow bar. So the magnitude is 1200 Newton. Find the braking force. Okay, so if I'm going to isolate the car, and I'm going to change because I've put this in the wrong direction. This will be going this direction. Okay, so I'm going to rewrite all this equation here, so it's not so complicated. This will be minus F minus 200. So F is 1200 Newton. Okay. Find the braking force. So the braking force. So B F minus B. Again, you have resultant force equals to MA. So this is F. F now is to the right. Minus B, which is the braking force. Mass of the car is 1600 times minus 12. Okay. So your braking force is the force F, which is 1200 plus 19,200. So your braking force is 20,400. So now this problem on forces is always important that you draw direction of the forces correctly. So solve it. In this instant, when it brakes out, like the car has speed of 22 meters per second. At this instant, the car is 17.5 meters away from a stationary, which is directly in front of the car. So the car hits the van at a speed of 8 meters per second. So you have A is minus 12. S is 17.5 meters. U is 22. You're going to still use the Subat formula when you're asked to find V. Okay. So V square equals to U square plus 2AS. Equals to 2 square plus 2. Meters per second. Okay. After the collision, the van starts to move with speed 5 meters per second. The car and trailer continue moving in the same direction with speed 2 meters. Find the mass of the car. So this is mass and trailer of the car and trailer, which is 2,300 kilogram. This is the van, which is stationary. This is 8 meters per second. This is before the collision. After the collision, this moves at 2 meters per second and the van moves at 5 meters per second. So, law of conservation of momentum. 1,300 times 8 plus the momentum of the van, which is 0, equals to 1,300 times 2 plus 5 times m. M equals to 2300 times 6 divided by 5. 2760. Okay. Kinematics formula, integration and differentiation. The particle moves in a straight line through the point O. The displacement of particle from O is the time t second is s meter, where s equals t squared minus 3t plus 2. Between 0 and 6 seconds, s equals to 24 over t minus t squared over 4 plus 25 for t larger equals to 6. Find the value of t when the particle is instantaneously at rest during the first 6 seconds. Instantaneously at rest is when v equals to 0. So v is ds over dt equals t minus 3 equals to 0. So t equals to 1.5 seconds. That's it. At t equals 6, the particle hits a barrier at point P. Find the velocity with which the particle arrives at P. And also the velocity which the particle leaves P. Arrives at P. So plus 6 seconds v equals to minus 3. So at t equals to 6, v equals to 9. So this is a time we just p reach. So which the particle leaves P. So you need to do the second equation. So for the second equation, ds over dt minus 24 over t squared minus 2t. So this is when t is larger equals 6. So when t equals 6, p equals to minus 24 over 36 minus 6. 2 over 3. 38 minus 38 over 3 meters per second. So the minus tells you it is moving in the opposite direction. So the question asks about velocity. You must put it at its negative value. Find the total distance traveled by the particle in the first 10 seconds. Okay. E equals 0. S is So it stops when t equals to 1.5. So you got to find when t equals to 1.5. So when it stops, it will turn back. T squared minus 3t plus 2. (4.5) 2 minus 2.5. Minus 0.25. Okay. So at t equals to 6, you should get s equals to minus 0.25 for the second equation. So t equals to 6. S equals to 6 squared minus 3 times 6 plus 2. So this is 18, this is 20 meters. This is for first equation. 1, 0, t 6. So let's check. When t equals 6, for the second equation, it should equal 20. It is 24 over t 4 over 6 minus t squared over 4 plus 25. Okay, so this is 4. 36 over 4 is 9 plus 25. Okay, it is 20. So it is supposed to be in the same position. So when t equals to 10, s is 24 over 10 minus 10 squared over 4 plus 25. This is 2.4. 25 minus 25 plus 25. So equals to 2.4. Now let's find out. Okay. So this is the fixed point. T equals to 0. It's at 2 meters displacement. So it moves back to 0.25. T equals to 1.5. Turns back. To a displacement of 20. T equals to 6. This is 20. Somewhere along the way, from t equals to 6 to 10, it stops. So let's find out. Minus 24 over t squared minus 2t. Oops. Some problem with the question. Here. Oh, we rebound back. Okay. So over here hits the wall. And it rebounds back to two. Okay. So the distance is 2 plus 0.25 plus 22.25 plus 19.6. Okay. So 22.5, 23.1, 42.1, 44.1 meters. Good. Very tricky question. So that's it for now. Anybody who wants this paper can always put a comment, subscribe to the channel, and put down your email and I will email to you. Goodbye for now.